Now let us try to understand how we can implement a stack or a LIFO data structure using a simple array. Basically, we are going to learn two different operations, that is how to insert a data item in the stack and how to delete a data item from the stack. Now, whenever it comes to data structure, you have to follow some terminology convention. For example, in this stack, when you want to insert an element in a stack following this LIFO fashion, you call it push. And whenever you want to delete an item from the LIFO stack, you call it pop. Now let us try to understand how we can implement push and pop both utilizing a simple array. So whenever it comes to implementation or writing understanding the pseudocode or code, always try to visualize your old pancake example. What is being done over here? The waiter or waitress, they put the pancake one on top of another. So they start from the empty pancake and they put this pancake first, then on top of that pancake they put the other one, on top of that they put the other one, top of that they put the other one. So this way they are basically growing the top of the pancake by putting one pancake on top of other. And whenever you take it out, you are just taking the first pancake out, then take the second pancake out, then take the third, then take the next one. In this way you are basically decreasing the top layer of the pancake. So this thing can be done utilizing an array by using one single variable called top. How? Let us understand. So this empty plate of pancake, you can think of it as an empty array in C, empty array like this. So this array you can call it an array A, which is basically an empty array. And let us start from here. Now whenever we want to insert or push an item in this empty array, that push algorithm is basically shown in this else part. So what we do basically, first before pushing the element, we initialize this top to 0th index of the array, because array always starts from 0. So here it is, and top element starts from here. So this is just an empty stack of pancake or empty stack of data item, anything. So anyway, so now if we want to push an item, what we need to do, you can see that in the else part, what you have to do is you have to put the data item first. That means you are putting your pancake first. So let's say I want to put an integer called 000 in this place. It can be any data item, it can be a floating point number, character, whatever it is. I am just using 000 just to for easy understanding and resemblance with index 0 and 000 like this. So you can use anything. So anyway, so I put my first data item, that is 000, and then what I do is I increment top. That means top was 0. Now it is incremented top plus plus, and it is now 1. So now top is in here. Now whenever you want to push the next item, what you need to do, you have to again enter the data item at this top, this index. So let's say I want to put 111. So let's put it in here, that is data item is placed in a top and then top plus plus. So that means top is again incremented by 1, which is, so now top is top plus plus incremented from 1 and it became 2. Now if I want to insert another item, let's say 222, so let's put it, so it will become 222, and what you need to do is you have to increment the top once again, so top will become 3 now. And now if I just want to insert another item, what will happen? Now so it will enter the data item first. So let's say I want to enter 333 over here, and then top is incremented by 1, that is top plus plus equals 4. Now what will happen? Now see, the maximum capacity of the array, let's say this one, is achieved. So now what will happen? Next time if you want to push another element in the stack, it will go to this if condition and it will tell that alright, the stack is full and you cannot push any other new item. So it is not possible, and sometimes this stack full condition, we give it another name which is called stack overflow. So that's about push operation. Now the pop operation, after understanding this push operation, pop becomes very simple. It's just the opposite. And here in this else block, you can see the pop operation over here. So what you need to do is basically, so top is now 4. So now in popped item, so whenever you want to pop an item, you have to save the first item in here. So the first item, whenever you save the item, you can do whatever you want to do in with this item. I just saved it in a variable called popped item, and that's it, just to show you that okay, that element is taken out. So what I have done basically, so I have just taken out the popped top element, and then I have decremented this top. So now from top equals 3, it becomes, so top equals 4, and it becomes top equals minus minus, so it becomes 3 now. Okay, so top was 4 previously and now it became 3. Next time when I want to pop another item, what do you need to do? First pop one item and save it inside the popped item. So that becomes like 222 is removed from the stack. Removed from the stack or popped from the stack, and top become minus minus equals 2. So top is decremented by 1. Next time when you want to pop the next element, so again take out the next one, that is 111, and decrement the top once again. So top minus minus is now 1. So this way. And finally, when you do the pop once again, just the same way, pop 000, save it inside this popped item and decrement the top again, and now it is 0 from where it started. Now when you want to decrement another item, then what will happen? Then it directly goes to this if code block, that is if top is less than equals 0. So top value is already 0, so it will tell the user that well, the stack is empty, so there is nothing to pop from the stack. And this type of condition in data structure terminology, we call it stack underflow. So this is how you can implement the push and pop operation of a stack utilizing an array.